Here's my Molarity Fakie tutorial. The basic idea is that molarity, that's capital M, is moles per liter. So it stands in for moles per liter, but you also need to calculate moles over liters to generate the value of molarity. So on number 1 and 2, we're going to start off kind of slow. They just tell you the moles, they tell you the liters of solution, and you can just divide, and that gives you the molarity. And you could also write it as moles per liter. I mean, no one really cares, but it seems like more work, and most people just use capital M. In this case, it doesn't matter what the chemical was because we already have the moles, that's the particles, number of these. And we're not talking about the mass or anything, so it's not going to really matter what the formula was until we start involving stuff like grams. On number 2, we also have the moles, we have the liters, and we can just divide. How about we skip to number 4? The tiny trick here is that they don't give us liters exactly, they give us milliliters, but to go from milliliters to liters, you just push the decimal left 3 spots because it's 1,000 milliliters for every 1 liter. Or you could say 1,000 milliliters is a liter, and that's a difference of 3 decimal points, decimal spots. And if you measure with a bigger unit, you get a smaller answer for the same thing, because it's the same amount of solution, right? It's just whether we want to express it in milliliters or liters. So if you use a bigger unit than you used to, you get a smaller number than you used to. And let's pretend that we go the other way. If you use a smaller unit than you used to, you get a bigger number than you used to. So we're just going to take the moles and put it over the liters. But remember, you have to use liters and not milliliters. And here I was just coaching some mental math. That's 1/4, huh? So we could rewrite it this way if we wanted to. And another way to think about division is how many 1/4 can you cram into 2? So if you can picture pizza pieces that are 1/4 of a whole pizza and the space for 2 whole pizzas, how many 1/4 pizzas can you fit into the space for 2? And the answer is 8. I'm just demonstrating that we can do this mentally and without a calculator. And we get 8 is the molarity. On 3, we want molarity. So I know I need moles and liters, except they gave me liters, so that's easy. What I need to go chase down is moles. And so I have a hole in my information right here. I don't have this number yet, which is why I went and did all this. And the way to think about it would be, what could give me moles, though? Well, what do we see up here? What other information do we have? I have grams of a certain chemical, and we've done that many times. We've turned grams into moles. So I can put the grams, say I want moles, and then this is the hole in my information. I need the molar mass. So I go to the periodic table and get the molar mass, add it up. Don't forget to multiply here. And put the molar mass here, divide gives me moles, and I did all that so I could put it here, and then I divide and get molarity. On 5, we calculate the molarity, so I want molarity, but I have liters. Well, in a minute I do, right there. Push the decimal left 3 spots. And again, I need to go get the molar mass so I can turn the grams into moles because I know I need this number. And once I get the moles, I can divide and get molarity. Number 6 is basically the same thing. On 7, we're going to kind of turn this around. We want mass. Well, what kind of thing could I turn into grams, which measures mass? And it might not be super obvious at first, but I could turn moles into that, right? So if I could get moles, I could say, oh yeah, I could turn that into grams. And the way to do this is say, I know the molarity. I know the molarity. I know over here. And I know the liters. And remember, inside molarity is moles and liters. I can put down the liters, I can put down the molarity, and I can multiply this over and solve for moles. So moles turns out to be this. And then I can go to the periodic table, get my molar masses, multiply through, add them up, and that is my molar mass to take my moles to grams, multiply and get grams. on 8, I guess I wasn't done. What mass would you get? And I got distracted. And so this is going to be 71. And you know what? I don't remember 8 times 16, so I'm going to do it for real. 128. I'm going to add all that up, plus 71 plus 55.8. And so the molar mass is 254.8 grams per mole. All right. Now, why did I know to do that? Because I want mass in the end. And I know molarity. And I know, well, I know liters basically there. And again, I can multiply this times that and get moles. And now I want to convert my moles to grams. And I'm going to use that number in here, of course. And we're going to multiply through, so times 1.225, and that will be the final grams because the moles will cancel out here. And let's just call it 312.